photograph showed white, crystalline deposits on power cables within a power panel. These deposits were identified as ammonium chloride. Ammonium chloride is a chemical compound commonly used as a fertilizer. The presence of these deposits on electrical components poses a significant safety risk. The formation of ammonium chloride deposits in this context is typically attributed to a combination of factors. Firstly, high humidity plays a crucial role. When the air is saturated with water vapor, condensation can occur on cooler surfaces such as power cables. This condensation creates a thin film of water. Secondly, poor ventilation exacerbates the problem. Inadequate air circulation prevents the dispersal of moisture and airborne contaminants, allowing them to accumulate within the enclosed space of the power panel. Thirdly, the presence of ammonia in the air is essential for the formation of ammonium chloride. Ammonia gas can originate from various sources, including agricultural activities, industrial processes, or even the decomposition of organic matter. When ammonia comes into contact with the condensed water on the power cables, a chemical reaction occurs, resulting in the formation of ammonium chloride crystals. The chemical reaction is as follows. Ammonia, denoted as NH3, reacts with hydrochloric acid, denoted as HCl, to produce ammonium chloride, denoted as NH4Cl. The deposits of ammonium chloride on power cables present a considerable safety hazard for several reasons. Ammonium chloride is a conductive salt, meaning it can facilitate the flow of electrical current. When ammonium chloride accumulates in the insulation of power cables, it can create a conductive pathway between the conductors or between a conductor and ground. This conductive pathway can lead to a short circuit. A short circuit occurs when an electrical current bypasses the intended circuit path and flows through an unintended path of low resistance. Short circuits can generate intense heat, which can ignite flammable materials in the vicinity, leading to a fire. In addition, the rapid surge of current during a short circuit can damage electrical equipment and even cause an explosion. The presence of ammonium chloride can accelerate the corrosion of metal components within the power panel. Corrosion is the gradual degradation of materials, typically metals, due to chemical reactions with their environment. Ammonium chloride can act as an electrolyte, facilitating the electrochemical reactions that drive corrosion. Over time, corrosion can weaken the structural integrity of electrical components, leading to equipment failure. Electrical connections, such as bolted joints and crimped terminals, are particularly vulnerable to corrosion. Corrosion at these connection points can increase electrical resistance, leading to overheating and potential fire hazards. To mitigate the risks associated with ammonium chloride deposits, several corrective actions should be taken. Firstly, the power panel should be thoroughly inspected to assess the extent of the contamination and any damage to electrical components. Secondly, the ammonium chloride deposit should be carefully removed from the power cables and other affected surfaces. This can be accomplished using a combination of physical cleaning methods, such as brushing or wiping, and chemical cleaning agents specifically designed for removing salt deposits. When using chemical cleaning agents, it is essential to follow the manufacturer's instructions and take appropriate safety precautions to avoid skin or eye contact. Thirdly, the source of the ammonia contamination should be identified and addressed to prevent future occurrences. This may involve improving ventilation in the area, controlling ammonia emissions from nearby sources, or implementing air filtration systems to remove ammonia from the air. Fourthly, the ventilation within the power panel should be improved to reduce humidity levels and prevent condensation. This can be achieved by installing ventilation fans or louvers to promote air circulation. Additionally, the power panel should be sealed to prevent the ingress of moisture and contaminants. Fifthly, regular inspections and maintenance should be performed to detect and address any signs of ammonium chloride contamination or corrosion. These inspections should include visual examinations of power cables, electrical connections, and other components, as well as electrical testing to identify any signs of insulation breakdown or increased resistance. In addition to these corrective actions, it is essential to implement preventative measures to minimize the risk of ammonium chloride formation. These measures include controlling humidity levels in the area, improving ventilation, and preventing the release of ammonia into the air. By taking these steps, it is possible to maintain the safety and reliability of electrical equipment and prevent the hazards associated with ammonium chloride contamination. When dealing with electrical equipment, it is always important to follow safety precautions to protect oneself from electrical shock and other hazards. These precautions include wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing the equipment before performing any work. It is also important to have a thorough understanding of electrical safety procedures and to follow all applicable codes and regulations. The presence of such deposits highlights the importance of regular electrical inspections and preventative maintenance. Identifying and addressing potential issues early can prevent more serious problems, ensuring electrical systems operate safely and efficiently. The situation emphasizes the need to understand the environmental factors that can affect electrical equipment. High humidity, poor ventilation, and the presence of specific chemicals can all contribute to unexpected problems, like the formation of ammonium chloride deposits. To elaborate further on electrical safety, it's crucial to understand the potential dangers involved in working with electrical systems. Electricity always seeks a path of least resistance to ground, and if a person becomes part of that path, they can experience a range of injuries, from mild shocks to severe burns and even death. Therefore, adhering to strict safety protocols is paramount when working with or around electrical equipment. One of the most fundamental safety rules is to always energize the circuit or equipment before starting any work. This means turning off the power at the source, such as a circuit breaker or disconnect switch, and verifying that the power is indeed off using a voltage tester. It's also important to lock out and tag out the disconnect switch to prevent someone from accidentally re-energizing the circuit while work is in progress. Personal protective equipment, also called PPE, is essential for protecting workers from electrical hazards. This includes items such as insulated gloves, safety glasses or face shields, and flame-resistant clothing. Insulated gloves are designed to protect the hands from electrical shock, while safety glasses or face shields protect the eyes from arc flashes and flying debris. Flame-resistant clothing provides a layer of protection against burns in the event of an arc flash. Another critical aspect of electrical safety is maintaining proper clearances around electrical equipment. Clearances are the minimum distances that must be maintained between energized equipment and other objects, including walls, ceilings, and other equipment. These clearances are specified in the National Electrical Code, also known as NEC, and are designed to prevent accidental contact with energized parts. Regular inspections of electrical equipment are essential for identifying potential hazards before they lead to accidents. Inspections should include checking for damaged insulation, loose connections, and other signs of wear and tear. Any problems that are identified should be corrected promptly by a qualified electrician. Grounding is another essential safety measure that helps to protect against electrical shock. Grounding provides a low-resistance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and energize the circuit. All electrical equipment should be properly grounded in accordance with the NEC. Arc flash is a dangerous phenomenon that can occur when a short circuit or other fault causes a sudden release of electrical energy in the form of an arc. Arc flashes can generate extremely high temperatures, which can cause severe burns and other injuries. To protect against arc flash hazards, workers should wear appropriate arc-rated PPE, such as arc flash suits, helmets, and gloves. Electrical safety training is essential for all workers who may be exposed to electrical hazards. Training should cover topics such as electrical safety principles, safe work practices, and the proper use of PPE. Workers should also be trained on how to respond to electrical emergencies such as fires and shocks. In addition to these safety measures, it's also important to be aware of the potential hazards associated with specific types of electrical equipment. For example, overhead power lines pose a significant electrocution hazard, and workers should always maintain a safe distance from them. Underground electrical cables can also be hazardous, and workers should always call before digging to avoid damaging them. By following these electrical safety tips, workers can significantly reduce their risk of electrical injuries and ensure a safe working environment. These safety tips are very important to review to prevent serious injuries or death.